In the field of graph theory, we say that two graphs are isomorphic if they have the same structure. So two graphs, let's call them G and H, are isomorphic if the following three requirements are met. The first requirement is that G and H have the same number of edges and vertices. The second requirement is that G and H have the same degree sequence when we write the degrees in non-increasing order. And the third requirement is that G and H have the same cycle structure. So I'm going to work through 4 different examples and show you how to determine if two graphs are isomorphic. All right, so here's our first example. We have graph G and graph H, and we want to know, are they isomorphic? So the first thing we need to check is, do they have the same number of edges and the same number of vertices? So in this first graph, we can see that there are a total of 1, 2, 3 vertices. So we'll write the number of vertices is 3. We can also see that there are 2 edges in this graph. So the total number of edges is 2. And for graph H, we can see that there are 1, 2, 3, 4 vertices, and there are 1, 2, 3, 4 edges. So right away, we can see that graph G and H do not have the same number of vertices, and they don't have the same number of edges. So we don't even need to check the other 2 requirements. We already know that these 2 graphs are not isomorphic. So that was a very simple example to start with, but that just shows that that's what you should check first. Check if 2 graphs have the same number of edges and vertices, because if they don't, then right away you know that they are not isomorphic. All right, let's check out our second example here. We have graph G and graph H. To check if they're isomorphic, let's first check, do they have the same number of edges and vertices? So in graph G, we can see it has 1, 2, 3, 4 vertices, and it has 1, 2, 3, 4 edges. Now in graph H, we can see that has 1, 2, 3, 4 vertices and 1, 2, 3, 4 edges. So graph G and graph H both have the same number of vertices and the same number of edges. So now we can move on to the second requirement, and let's check if they have the same degree sequence. So the degree of a vertex is just the number of edges that are attached to it. So for example, for this vertex right here in graph G, we can see it has 2 edges that are attached to it. So it has a degree of 2. So let's write that. We'll just write a 2 right here. And then the same thing with this vertex. It has 2 edges attached to it. So it has a degree of 2. And we'll find that for each of these vertices in graph G, they all have a degree of 2. Now, if we look at graph H, this vertex right here, it only has 1 edge that is attached to it. So it has a degree of 1. Now, right away, we can see that graph G only has vertices with degrees of 2, and we already have a degree of 1 right here. So we already know their degree sequence will not be the same, and the graphs will not be isomorphic. But just for a little bit of extra practice, we can go ahead and label all of the degrees of graph H. So if we were to write the degree sequence of each graph, the degree sequence of G, we can write it as D sub G, would be 2, 2, 2, 2. So these are just the numbers that describe the degrees of each vertex in the graph. And if we were to write the degree sequence for graph H, we could say D sub H is equal to, now we're going to write the degrees in non-increasing order. So in other words, let's start with the highest degree, which we can see is a 3 in graph H. So we would write 3, then 2, 2, 1. So we can see that the 2 degree sequences are not the same. So in other words, these 2 graphs do not have the same structure, and they are not isomorphic. So for our final answer here, we'll say not isomorphic. All right, let's check out example number 3 now. Are these 2 graphs, G and H, isomorphic? So first let's check, do they have the same number of edges and vertices? So in graph G, we can count 1, 2, 3, 4, 5, 6, 7, 8 total vertices, and we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total edges. Now for graph H, we can see there are 1, 2, 3, 4, 5, 6, 7, 8 total vertices, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total edges. So these 2 graphs have the same number of edges and vertices. So now let's move on to requirement 2. Do they have the same degree sequence? So we can go ahead and go through each vertex in graph G and label its degree. So if we label each degree and then we write out the degree sequence for graph G, here's what that looks like. And then we can repeat this process for graph H. Now, when we do that, we'll find that graph H has the exact same degree sequence as graph G. So the first two requirements are met. Both graphs have the same number of edges and vertices, and they have the same degree sequence. So now we can move on to the very last requirement. Do they have the same cycle structure? Now, this third requirement is the most tedious to check because it involves checking if each of these cycles in each graph are the exact same. So remember, a cycle is just if we start at one vertex, let's say this vertex of graph G, and we traverse through the graph in a certain manner and we end up back at the same vertex, that's a cycle. So we're checking, are the cycles the same for both graph G and graph H? And when you're checking this third requirement, it helps if you can just try to identify a cycle that is different between the two graphs. Because if there's a cycle that's different between them, it means they don't have the same cycle structure and thus they're not isomorphic. So for this particular example, let's look at graph H. We'll notice that there are 4 vertices in this graph that have a degree of 3. So these 4 vertices right here. What we'll notice is that if we make a cycle connecting them, it would be 1, 2, 3, 4. The cycle would have a length of 4. But we'll notice in graph G, if we also look at the vertices that have a degree of 3, so this vertex, this one, and this one, it's not possible to form a cycle length of 4 between these 4 vertices. So because we can't form a 4 cycle using those same vertices, it means that these two graphs do not have the same cycle structure. And ultimately, it means that G and H are not isomorphic. All right, let's try one more example. Example 4. Are graphs G and H isomorphic? So first let's check, do they have the same number of edges and vertices? So when you go to check that, you will find that yes, both graph G and H have 5 vertices and 5 edges. So now you can move on to requirement 2. Do they have the same degree sequence? So let's go ahead and write out the degree sequence for each graph. So when we check that, we will find that yes, they have the same degree sequence. So each vertex in both graph G and H has a degree of 2, or in other words, 2 edges that are attached to each vertex in the graph. So both of their degree sequences are just 2, 2, 2, 2, 2. So since they have the same degree sequence, now we can move on to the very last requirement and check, do they have the same cycle structure? So if we look at graph G, let's consider this vertex at the very top right here. If we make a cycle starting and ending at this vertex, it would have a length of 1, 2, 3, 4, 5. So a cycle length of 5. And then if we just move through the graph and we consider every possible cycle, so if we start with this vertex instead, we'll find that it also has a cycle length of 5. So 1, 2, 3, 4, 5. So what we're going to find is that there are a total of 5 cycles that we can make in this graph, and each has a cycle length of 5. Now, if we consider graph H, if we do the exact same process, so let's start with this vertex at the top. If we work through this cycle until we're getting back to this vertex, that would look like this. 1, 2, 3, 4, 5. It also has a cycle length of 5. And if we just move through the graph in this manner, so if we then start with this vertex and we move through the graph until we're back to this vertex, we would find that it's 1, 2, 3, 4, 5. Another cycle of 5. What we're going to find is that it also has 5 cycles, each of length 5. So we will find that graph G and H both have the same cycle structure. So because all 3 requirements are met, we would say that G and H are isomorphic. So for our final answer here, we will write G and H are isomorphic. And if we wanted to write that mathematically, we would write it like this. G is isomorphic to H. So hopefully you saw through these 4 examples that if you just work through each of these 3 requirements in this order, you should be able to determine if any 2 given graphs are isomorphic or not.